Okay, we're looking at lesson 5.9, properties of logarithms. So, we've got 5 properties of logarithms here. B to the log base b of m exponent equals m. Log base b of b to the m is equal to m. Log base b of m times n equals log base b of m plus log base b of n. Log base b of m divided by n equals log base b of m minus log base b of n. And log base b of m to the k power equals k times log base b of m. So the k just kind of moves out front here. So the third and the fourth are directly related to properties of exponents. Remember that with exponents, when we multiply with the same base, then we add the exponents, and that's kind of the same thing. We have the base, common base, we're multiplying arguments here, then we can separate them by addition. Same thing with division. We have common base, we're dividing. Notice we're going from on both of these, we're going from one log to 2 separate logs. This one down here, what happens is the exponent just moves out front. All right, the exponent moves out front. We're going to verify actually properties 1 and 2, and they're directly related to the fact that exponent and logarithm are inverses of each other. So properties 1 and 2 show that b log base b of m equals m and log base b of b to the m power is equal to m. These properties follow from the definition of an inverse function. Okay, remember that if we do composition of functions with a function and its inverse, we get x. So f of f inverse of x equals x, and f inverse of f of x equals x. Composition of functions here. So, knowing that these are inverses, we're going to say if f of m equals b to the m power, and its inverse, f inverse m, equals log base b of m, these are inverses of each other. Then, if I do f of f inverse, I'm going to do f of the inverse function log base b of m. All right, I'm going to take this and put it in for m, so I get b to the log base b of m, and I know that by definition this has to equal m, so I just verified it. B log base b of m equals m. Okay? Doing it the other way, f inverse of f of m. So I've got f inverse of b to the m power. I'm going to take b to the m and plug it in for the m here. I get log base b of b to the m power. And again, I know because it's true that these are inverses of each other that this has to be equal to m. So log base b of b to the m equals m, which is what the second property tells us. So let's use this then to do a little simplification. We're evaluating 5 to the log base 5 of 18. So when this base here is the same as the base of the logarithm in the exponent, then our answer is going to be that argument in the exponent. This one's like the second one, like property 2, log base 3 of 3 to the x minus 2. When the base here is the same as the base here, our answer is x minus 2. All right. Remember that ln is base e, so this again is using property 2, log base e, natural log, which is base e of e to the 3t. My answer is 3t. All right, so we're going to move on here. Use properties of logarithms to evaluate each expression without using a calculator. All right, so log base 5 of 5 to the root 3. We're going to move this out. We're going to just say log base 5 of 5 to the root 3. That has to be root 3 by property 2. Okay, this one, I want to use property 1, but right now I've got 2 different logarithms up in my exponent. So I want to combine those to a single logarithm. So first thing I'm going to do is I'm going to move this 2 and make it into an exponent on the 3. So this will be log base 4 of 6 plus log base 4 of 3 squared. Now I'm going to combine those using property 3. I can combine those to a single logarithm, log base 4 of 6 times 3 squared. All right, since I'm adding two logs, I can change it to a single log where I'm multiplying the arguments. And now I've got the base here of the exponent with the base of the log are the same. Therefore, this is equal to 6 times 3 squared, 9. 6 times 9 is 54. All right. Expressed as a single logarithm or rational number. So on these problems, we want to take something that's expanded out and combine it, condense it as much as we can. Okay, log base 2 of 48 minus 1/3 log base 2 of 27. So I'm subtracting here. Well, I'm going to start with the 1/3. I'm going to take this 1/3. It's going to become an exponent on the 27. 27 to the 1/3 power. Okay. Then I'm going to, since this is log minus log, I'm going to use property 4 to write this as a single log, log base 2 of 48 divided by this one. The 27 to the 1/3 power is really the cube root of 27. Okay, so this is log base 2 of 48 divided by 3. Cube root of 27 is 3. 48 divided by 3 is 16. Log base 2 is 16. And 2 to what power equals 16? That would be 2 to the 4th power. So all of this equals 4. All right, this one. I've got log base 1/2 times log base b of m plus log base b of n minus log base b of p. So I'm going to combine. I've got log plus log minus log. I'm going to multiply the ones that are added. We'll combine these into a single log. I still have this 1/2 out front. Log base b of m times n, and then minus log p, I'm going to divide by p. M times n over p. Now the 1/2 becomes an exponent. It's like log base p of mn over p to the 1/2 power. 1/2 power means square root. So the square root of mn over p. Oops, log base b of that. Sorry about that. Log base b of square root of mn over p. Expand as much as possible using the properties of logs. So now we're going to do the opposite. We're going to expand it as much as we can. So if I have a number, I'm going to write it as prime factorization. And 18 I can write as 2 times 3 times 3. 2 times 9 is 18. 2 times 3 squared. Okay? So I'm going to separate these apart. I'm going to say log 2 plus log 3 squared. And finally, I'm going to move this 2 out front. So I'm going to have log 2 plus 2 log 3. And that will be my answer there. Log 2 plus 2 log 3 is the same as log 18. Ln, natural log of x times square root of 1 plus x squared. So I can write this as natural log x plus natural log of the square root. Well, let's write that. I'm going to change this. 1 plus x squared to the 1/2 power. That's the same thing as the square root of 1 plus x squared. And then I'm going to move this 1/2 up front. So ln x plus 1/2 ln of 1 plus x squared. And that's pretty much all I can do here. I cannot split apart. I can't distribute ln of 1 plus x squared. All right. In fact, this last little note at the bottom of the page kind of tells you that. Log of m plus n cannot be rewritten using the properties of logs. So that's what I have here. Ln of 1 plus x squared. I can't really separate those out. Okay. So practice with your properties. Let me know if you have any questions. I hope you are doing all right, and I'll talk to you later.